Right. In the previous class, we were trying to understand what makes network possible, even though we have multiple vendors, even though we have different architecture on computers and routers and switches. What makes them work together? It is this interconnecting. It is that interconnecting system that makes the device to connect openly. See the name, open system, regardless of their architecture, regardless of their make, vendor. All the devices, Cisco routers, HPE routers, and Arista, Huawei, Zati, Cisco firewall, Palo Alto firewall, all can work together openly. All the systems are united openly, interconnected and communicates openly. It is all because of this reference that everyone has referred, the model that everyone has referred, open system interconnect model, open system interconnect. And I explained to you in the previous class that there are 7 layers or 7 functions that are carried out to send the data from one place to another successfully. This is layer 7. See, our data is created in layer 7. See, when you open a chat window, what it is? It's an application. It's a network application. It's an application that can interact with the network. It is an application that can send data using network. See, the word MS Word which I have kept open is not a network application. This cannot interact, it's standalone. But the mailbox or the messenger box, the Facebook Messenger, instant messengers, Google Chat, all these are applications that can generate data, that can send data via network. So you have such application and it is generating data. This Google Meet that we are using now is an application layer. That is the one which is copying my voice. My voice is the data here. Now, that need to be presented to the network. That need to be given to the network in a network understandable manner. See, I'm using human voice. I'm not using network language here. I'm using English language, human language. The data that application layer is getting from my voice is not a network language. That's a voice. That voice need to be interpreted, represented to the network so that network will understand what it is. See, when I am talking, it is a voice data. When I am writing, it is a video data. These are not same. These are not same. You and me knows. How network knows? When I say a word, it's a voice data. But now when I write hello here, it's another type of data. It's not same. It's video. When I write hello, you see hello there. When I say hello, you hear hello there. It's two different type of data. Network also understands. That is why you are able to see it there as well as hear. You see as well as you hear. How is that possible? Because network also can differentiate between the voice hello data and the video hello data. How is that possible? It is possible because of the presenter. The presentation makes the network to understand this is different and that is different. This data need to be sent to the speaker and that data need to be sent to the screen. Isn't it? Your laptop is showing you hello. It is on the screen. Your laptop is also shouting hello when I shout from here through the speaker. So, the presentation has presented in such a way that network also can differentiate the types of data. For example, you are telnetting from application layer. You use putty or putty. The putty can be used for doing SSH, telnet. Now, when you are doing SSH, the presentation layer presents to the network that this is a telnet. When you do SSH, presentation layer again says, hey, this is not a normal unencrypted, not a normal plain text. It is an encrypted data. So presentation layer interprets our human understanding to the network understanding. Some people will call machine understanding. Yes, it's okay to say that. So presentation layer takes care of presenting our data, to the network. Application layer is the place where you generate. Presentation layer is where the generated data is translated, converted to a network understandable data. See, network need to understand first what it is. Only the network can send it with the meaning of what it is. So your laptop will understand how to deal with it. So presentation layer, the name is not just given like that, presentation layer. See, it's a very deep meaning in it. It shows what it is doing. The presentation layer, the name shows that this layer is responsible for presenting our data so that the network will understand it. And the receiving device, your laptop's presentation layer will see what my presentation layer has told and use it accordingly. My presentation layer says this is a voice traffic, that's a video traffic. Your presentation layer can easily understand that what my laptop said in the presentation layer and takes the data and uses it according to what my laptop has told your laptop. See, my laptop is clearly telling these are all voice traffic, send it to speaker. These are all video traffic, send it to the video, the screen, the display. So your presentation layer understands how to use the data. That's why presentation layer is important. Next is the session layer. Now our data goes to the session layer. What is the responsibility of session layer? It is to provide a time frame. It is to say when this traffic should leave, within what time the response should come. If the response don't come, action can be taken. Maybe the packet can be resent. So session layer is taking care of the session. For example, when you ping, you get a reply because the reply came on time. If the reply did not come, session layer will say timed out, request timed out. See? So session layer is keeping track of all the data that is sent, all the data that is coming in, and if any data is going beyond the default normal time frame, it says timed out. So the session layer is related to the time. See, parallelly you can have multiple sessions. And they all use the processor according to the session time given. So there won't be a conflict. We may think that it is parallelly being sent and received, but it is not parallelly. There is a microsecond time difference. Always. Between one session and the other. So that there won't be a conflict. Like, when you go for an interview, if there are too many people for interview, they give let's say you're going for a visa interview. So they give you a time frame. Come in between 9:30 to 9:45. So when you go there, in the embassy, there is a person waiting for you knowing that you will be coming. Because they gave you an appointment time. So no one else will be there because the time is given for you. When you go 15 minutes late, then you will not be allowed. The reason is there is someone else need to be focused. So the session layer is purely taking care of session so that there won't be a conflict. Now, once the session layer provides the time frame when the packet should leave, when the packet should use the network, it goes to a layer called transport layer. This is the middle layer, you see. On top you have 3, on bottom also you have another 3 layer. This is the middle layer, transport layer. Now this transport layer, as the word says, transport. This is responsible for end-to-end transportation. End-to-end transportation. Say for example, I have 20 blind people. I want them to go from my home to a church. 20 blinds are there in my home. I want to move them from my home to church for another 5 hours. They have a prayer here. So what I do, 20 people I need to move. Then I call for cab so that I can put, or 5 cab, so that I can put 4 people, 4 blind in each cab. Four blind in each cab, and they all can go and reach on time. You see, this is what transport responsibility, transport team responsibility. They need to decide how many cabs we need. According to the size of the data, the cab, the segmentation, the cabs are determined. You see, the physical wire that you are connecting, or the Wi-Fi signal that you are connecting, that has got a limitation. According to the limit, what is the limitation of this cab? 4 people you can send in the cab. 4 passengers in a cab. Only 4 passengers can easily, comfortably go. 3 at the back, 1 in the front with the driver. 4 passenger. Then how many cabs I need for 20 blind? 5. This is what actually done in transport layer. According to the capacity of the cab, I decided how many cabs I need. According to the capacity of the media through which you are going to send the data, transport layer will segment, like I segmented 4 people in a group, 4 people in a cab. That is what one segment. So totally how many segments? 5 segments. Actually it is one group of people, one data. But that cannot go all together. So I segmented into 5 groups, 4 passenger each. Each group is a segment. See the word transport layer, very meaningful. For easy transportation, that segmentation is needed. Right? So transport layer is meant for segmentation, for transportation. For easy transportation, segmentation need to be done. The size of the segment is determined according to the media that you are going to use for communication in the physical layer. Transport layer takes responsibility of this segmentation. Next, after transport layer job is done, there are many more jobs that transport layer does. We will discuss in detail a bit later. Now let me move on to the next layer. Each segment will get an IP address. IP address, as I said earlier, it's a logical address. IP address is a logical address because the IP address can be changed. So the source IP address and the destination IP address is added to the segment, and now it gets a new name called packets. The protocol IP works in this layer. That's why the address also called as IP address. This can be IPv6 or IP, or even old technology like Apple Talk. Apple Talk is another network layer protocol. Olden days we used to have IPX. But now we don't have those things, so we have IP address, source and destination added. My IP address and your IP address. Mine is a source, yours is a destination added. Next is the data link layer, where the packet is added with additional information called MAC address. MAC address are not logical, they are physical. They are burnt in, they are not changed, they are permanent. Yeah. So the IP address changes, MAC address, they don't change. Okay, now once the MAC address, source and destination MAC address is added, the data is now converted into the frame. It gets a new name called frame after adding MAC address, and now that is converted into bits and bytes and sent over the media. That media can be Ethernet or fiber channel, or it can be radio wave signal, whatever, but it is going to be sent in the form of bits and bytes. So this is responsible for the connectivity. That is why it is called as physical layer. It can be sent through a Wi-Fi transmitter, or it can be sent through a transceiver, Ethernet, or FC, fiber channel. Now this is how the 7 layer has got 7 functions. Only then this packet is eligible to be sent in the network. If not, the network cannot carry the packet. In fact, if any one of this layer is missing, the packet won't be even sent out of my laptop. Yeah, my laptop needs to know all the 7 layers to send that packet out. Thousands of packets are sent out in a second from my laptop by adding all the 7 layers. See, to understand this layer, it may take hours together, but computers don't take that many hours to prepare one packet, just a few microseconds. That's how you are able to hear my voice. Yeah. Right. So OSI is a logical layer. It is helping us to understand what happens first and what happens next. And it is important for a packet to be sent out, to be eligible. When you open a laptop or a computer or a router, you don't see these layers physically. These are all logical functions that need to be carried out by the chipsets, the motherboard that you have. The manufacturer have to put all the necessary programs inside the chipset, in that ROM, read-only memories. To do these things, the drivers that you install for network card, what they do these things. The operating system will do these top 4 layer. We don't do much with this 4 layer. It is the operating system, Microsoft or Linux. It's only these layer we work a lot. Engineers work a lot. IP address, MAC address, physical layer. Right. So we'll stop here and